Question number 5 here is calcium metal is a shiny, malleable substance that can conduct electricity. Calcium carbonate, on the other hand, is a hard, brittle-like, chalk-like substance. Now this is about materials, so the first thing I'm going to do is define what materials I have. I have calcium metal, first of all, and I have calcium carbonate. That's an ionic compound. And now I can start to think about how I might respond to whatever questions are asked here. Draw a labelled diagram to show the different bonding structure within calcium metal and calcium carbonate. So here I'm going to write calcium and say this is going to be my calcium and this one is going to be my calcium carbonate. Alrighty. In here I'm going to show what a calcium metal will look like, and it's just going to be a metal where I have a lattice of positive cations and a whole bunch of delocalized electrons here. So where that equals a cation and that equals a delocalized electron. Okay, so that's what calcium will be. It's just my structure of what a metal is. Over here for my calcium carbonate, I know it's ionic, so I'm simply going to draw what an ionic compound is going to look like. So again, chuck my atoms in, and ionic compounds are a lattice of positively charged and negatively charged anions and cations. I need to try and sort that one out there. That's a really badly drawn anion. But the positive equals a cation, and the negative here equals an anion. And the cation is Ca2 positive, and the anion is CO3 2 negative. And this one, the cation is Ca2 positive as well. So in each case, my cation is calcium 2 positive, but here my anion, my negative charge, is the CO3 2 negative, and over here my negative charge is my delocalized electrons, highlighting the fact that this here is the metallic bonding structure and this here is the ionic bonding structure. Provide a reason for the different malleability between these two substances. Now this is where I'm just going to be using my knowledge about malleability of my calcium metal, or my malleability of metals, and my malleability or brittleness of ionic compounds. So I'm going to do this here and talk about calcium. I'm going to talk about both of them. Okay, cations can move in the lattice and still be held by delocalized electrons, whereas with calcium carbonate, here I'm going to say that when a force is applied, like charged ions line up and repel, shattering the lattice. Again, talking about why this is a brittle chalk-like substance and this one here is a nice malleable metal. So that's the answer to question 5, a nice comparison of metals and ionic compounds.